the pollen, what we have in there. So this gives us a modern pollen rain as a reference data set for the Iceman. And here you have the results. So you have here the blue dots, which is the recent pollen deposition north of the main alpine ridge. And then you have these yellow dots, which is the recent deposition of the pollen rain south of the main alpine ridge. And the diagram has been read in this way, that the lower part here means low altitudes and the upper part here means high altitudes. And so according to this, we compare now the ingesta samples with this reference data set. And this tells us that round about 33 hours, starting with the rectum sample, he was in the timberline area, round about 2,300, 2,500 meters in the area of the Thiessen Valley, Schnalls Valley, and so on. Then, round about 9 to 12 hours before he died, he was in the valley bottom. And then he went up again and had his last meal in the helium sample, again at the timberline, in between 2 to 5 hours before he died. So these are now quite precisely short time movements, what we are having now, and these short time movements lend new weight to the disaster theory of Ötzi's death, Spindler presented 2 years after the discovery. So his hypothesis was that the Iceman returned in autumn from the high alpine pastures to his native village, and there he came into a conflict that severe that he had to flee from the community up to the high grounds which were familiar to him, and there he died of hypothermia at the end. Well, there are a lot of these parts in this hypothesis which are obsolete up to now. We've already heard it was not autumn, it was spring, and we also know that the cause of death is not hypothermia. He was killed. He was killed by a shot with an arrow in his left shoulder. And you see precisely the arrow on the left picture, and on the right hand you can see it corresponding. Above it you can see the arteria axillaris, which was hurt. And this caused a rapid bleeding to death. So he was killed within minutes concerning this. Here you can see this fissure of the arteria. Now, going back to the social context, who was the Iceman? There are several hypotheses, and all of these hypotheses are completely unsatisfying. Some of them say he was a hunter, a warrior, or an outlaw. He was a shaman. He was a miner or prospector. But the most accepted assumption for the moment is that he was a shepherd. There are several pros for being a shepherd. One is the grass cape. And the grass cape is the traditional costume of shepherds of the Balkan Peninsula until the 19th century. And pollen analysis in the vicinity of the discovery site reveal that there were pasture activities, and these had an impact on the alpine vegetation. There is only one complication: we don't have any kind of archaeological evidence concerning this. And therefore, we need to have a little bit a closer look on these pasture indicators. What we're having there, they're mainly herbs, and these herbs are favored by grazing. It's completely different from valley bottoms, because in valley bottoms, man creates new habitats. They create fields, what they don't do in high altitudes. In high altitudes, we only have grazing, and grazing causes mainly a manuring, a fertilization of the ground, and according to this, the vegetation mosaic changes in those who are not eaten by the animals because they are poisonous or sticky, and those who are favored by the dung as well as the urine. So the results from the pollen analysis Bodenschlager and his colleagues have undertaken reveal that we have an increase of these pasture indicators even 1,000 years before the Iceman died. And we have again another increase, what you can see right precisely at the time of the Iceman. The problem with these results is that at the same time we are having climatic variabilities. So around about 4,300 BC, there is a cool, cold climate situation. And again, when the Iceman was found around 3,300, we also have these cold climate conditions. And cold climate causes higher runoff. Higher runoff means more mineral particles are getting into the alpine grass mats, and this causes also fertilization. So we don't know precisely whether this signal is really a signal of human interference, or is this signal really a signal or just only a signal of climate. So according to this, the idea brought up the Iceman being a shepherd is also very closely related, because the discovery spot is located on the traditional transhumance route used since the Middle Ages from the Schnalz Valley to the alpine pastures north of the main alpine ridge, where they cross even the Niederjoch Glacier, as you can see. So according to these doubts, we made an additional test, because on the discovery site, thousands of dung pellets were collected, and these dung pellets, they belong to caprines. And with caprines we mean sheep-goat, but we can't separate sheep-goat from ibex or chamois. So the first thing will be to make a DNA analysis of these dung, probably to sort out comes this from livestock or not. But these analyses yielded no results. So according to this, we would like to answer this question again by analyzing where have these animals grazed. And this we can do again by a modern analog approach. On the one hand, to compare the subfossil dung pollen with modern pollen samples, but we made also an additional one. My collaborators had the delicate task to collect all the fresh dung from all the animals for a complete vegetation period, and this test is needed to check if valley bottom grazing and high alpine grazing can be separated. And what you can see here with the blue and the yellow dots is that they group right precisely together, and they are distinctly separated, so that we can say a